Hi, in this video I'm going to talk about architectural design overview. In software architectural design, this is the design process for identifying subsystems making up a system, and the framework for the subsystem control and communication is actually architectural design. The output for this design process is a description of the software architecture, and you have to capture this in its own design document. What we're doing here is an early stage of the system design process. We will go on in a later stage to actually decompose this design that we've come up with into a more detailed type design. This should represent a link between the requirement specification process and the actual detailed design processes. So this is at the boundary. Very often an architectural design at a high level can be carried out in parallel with some specification activity, but this is usually when you're coming down to the end of the requirement specification activities. It involves identifying major system components and the communication between those system components. So here's a kind of example. It's a box and line diagram, which is the type diagram we start with in describing system architectures. As you can see, it's for a packing robot control system, and what you should take away from this diagram is that it shows the major modules that are going to be designed in this particular system, and the kind of communication flows between each of the involved modules. So that brings me into architectural abstraction. Now there are two types. There's architecture in small and architecture in large. What architecture in small board is concerned with the architecture of individual programs. So at that level, you're concerned with a way that an individual program is decomposed into components. Architecture in large, on the other hand, is concerned with the architecture of like really big complex systems that include other systems, programs, and program components. Those kinds of enterprise systems are usually distributed over many different computers, which may be owned and managed by different companies. So for example, at the UE, we have PeopleSoft, which manages like the HR communication. We have Banner, which actually manages both student records as well as financial records and that kinds of things. So you could talk about architecture small for each one of those things. So Banner Finance as opposed to Banner recording as opposed to PeopleSoft HR. But architecture in large would be, okay, all systems as a whole, we could break it down into all of these different subsystems, and then architecture would be small, would be any one of those single ones broken down into its system components. So you have those levels of abstraction. Now if you have an explicit architecture, how this helps is that you could actually communicate with your stakeholders and focus their discussion around the major system modules and therefore what you're going to be building. You could also analyze the system in terms of how it's going to meet the non-functional requirements, and also you could allow large-scale reuse. So you could use a different set of systems that you might build later on, and you can make whole lines of different product architectures. So architectural representations, as you saw from the packing robot example just a moment ago, they're just usually simple informal block diagrams showing entities and relationships, and that's probably the most common method. These are criticized because they lack a lot details, and it's not really showing the types of relationship between the entities or the properties of the entities in the architecture, and it depends on how you're going to use those models. The requirements for model semantics usually depends on how the models are going to be used. Again, these diagrams are very abstract. I mean, they don't show the nature of the component relationships, neither the externally visible properties of the subsystems. Again, it's also useful for communicating with your stakeholders and for planning your project out, and we'll see when we get to detailed design how you could use that to further decompose the system into something more meaningful that you could actually start to implement. But right now we're at the high level thing. So it's about facilitating discussion about how we're going to start to design the system, and it acts as a way to document an architecture that has already been designed. And you really don't want to clutter these kinds of diagrams with lots of detail. You want to make it as relatable as possible, and you want to show a complete system model and the major components of the system. So architectural design is by its nature a creative process, so it differs from system to system that you're developing. However, you have to understand a number of common decisions span all design processes, and a lot of times that affects the non-functional characteristics of the system. You try to figure out things like, is there a generic application architecture that can be used, and we'll get to like some existing design patterns that you could use and architectural views you could use in subsequent videos. You ask things like how will you distribute the system amongst different systems? Are you going to host in the cloud? Is it going to be on these 6 different computers? Where is it going to reside? Is it going to reside on a phone? I don't know. Which architectural styles are appropriate? We'll get to architectural styles in a bit. With what approach will be used to structure the system? How will you decompose it into modules? And we'll get into system decomposition in a video all by itself. What control strategy you can use, how would you evaluate that architectural design, and how will you document it. You can go now and reuse those architectures in other systems of the same domain that reflect the same kind of concepts. You can build application product lines around a core architecture with some kind of variants that satisfy particular customer requirements. So let's say you're building security systems. You can build for boats versus houses versus, I don't know, warehouses. You could kind of tweak the system for every specific scenario, and you can get a product line around that kind of security kind of thing. The architecture of a system may be designed around one or more architectural patterns or styles. We will treat with some of the common architectural patterns and styles in a subsequent video. So that brings me to some of the characteristics of system architectures. The first kind of thing you want to look at is performance. When you're designing for performance, what you want to do is you want to take all the critical operations and keep them in very specific submodules, and you want to minimize the intercommunication between those submodules and others. And you want to use large grain rather than fine grain type components. The security, usually people use layered architectures with all of the critical type assets in the innermost layer, so it's actually protected from the outside world. In terms of safety, again, it's all about localizing all of the safety critical features in a small number of subsystems. In terms of availability, you want to include redundant components and mechanisms for fault tolerance. So for example, if you have a pump on a line that's actually pushing fluid through that line, perhaps if the pump fails, you want some kind of failover application that will turn on a secondary pump that will keep the system up and running. So it's about failure. It doesn't have to be a hardware kind of thing like the one you're explaining right now. You could have software components as well that are failover. So if you have multiple processes running on a computer, you can have a failover process in the same kind of vein. In terms of maintainability, and we'll come to discuss that perhaps in the last section of this course, you want to use fine grain and replaceable components such that you design for the maintainability. And that brings me to the end to this video. We will get into architectural views and architectural patterns in the next. Okay, bye.